All right, on to part B. Part B is about solving natural log equations. So this is your 3.8 part B. All right. So how do we solve equations? Well, these are our steps that we're going to follow. One, you simplify to one log on both sides, which is why we practice simplifying, right? To make sure that we can get down to one log. Then we're going to rewrite in exponential form using inverse operations and log properties. Then we're going to use inverse operations to isolate the variable. So our goal is to get whatever the variable is by itself. Then we're going to write the exact value and use a calculator to get an approximation. And you can always check your answer by plugging it back into the original equation. Capiche? All right, so we're going to start easy. So we have the natural log of x equals 2. Okay, the natural log of x equals 2 is good to go for us to take the exponential because the natural log is by itself. Okay, once the natural log is by itself, we're going to raise everything to the e power, e to that power. So it becomes e to the natural log of x equals e to the power of 2. Like we learned in 3A.7, once the bases are the same, all you focus on are the powers, right? Well, in this case, what happens here? They cancel out, right? So all we're left with is actually x equals e to the 2. So this is our exact, and we're going to plug that in the calculator to get our approximate. So going to my handy dandy calculator, open up Sylvie. Hey, girl. Sylvie have been doing some work. I'm going to type in e, so second, natural log. I'm going to put in e squared, and it says that it's approximately 7 and 389 thousandths. And that's my approximation. To get e on the calculator, you're pressing the blue button and log, not natural log, not log. Okay. All right. So this is the baseline. How do we feel about the base? Doable? All right. So now we're going to do it again. Is the log by itself? Log is not completely by itself. What do I need to do? I need to get it by itself. The only thing I need to do here is I'm going to reverse power property. So now it becomes 2 natural log of x minus 3 equals 4. What do I need to do to get the log by itself? This is the argument. Argument's fine. What do I need to move? The 2. So I'm going to divide both sides by 2. So now we're left with the natural log of x minus 3 equals 2. I have one log on the side. And so now I'm going to raise everything to the e power. Raising everything to the e power, what happens here? They cancel, so I'm left with x minus 3 equals e squared. Oh my gosh, do we know what e squared is? We do. That's so crazy. But before I can worry about it, what do I need to do to get x by itself? Last thing, add 3. So our x is approximately, this is our exact value. Our approximate is what we got for e squared, and what do we get for e squared? 7.389 plus 3. So our approximate value is 10.389. Again, this is our exact, and this is our approximate. Again, we're following those steps, and if I was unsure of my answer, what would I do? Plug it back in. Take that value and plug it back in for x to see if that's what I get. Okay? The value that you're plugging back in is the exact. Okay? The approximate is going to give you an approximate, which may not be exactly what you have, but you're going to take the exact value, and that's what you're plugging back in for x. Okay? Okay, question so far. All right. On example number 3, and again, ignore that it says 1. I know it's 3. Example number 3, before I can do anything, is there only one log on the left-hand side? No, so we have to condense. How can I condense this to one log? Which property? Quotient. So we're going to have to use quotient because it is being subtracted. So it becomes natural log of x divided by 6 equals 0. Now that I have one log on one side, I'm going to raise it to the e. That's to cancel out the natural log. And we're left with x over 6 equals, and anything to the 0 power is what? 1. What's the last step to do to get x by itself? Multiply both sides by 6. So we get 6. You get a 6. So x equals 6. And logically, when you look back, doesn't that make sense? Yeah. How else was I going to cancel out that natural log of 6? All right. I would like for you to try number 4. So I'll give you about a minute to try example number 4. Okay. So did you have to do any properties or condense? No. You should have just went straight into E. You get an E. You get an E. So when I apply E, this cancels out, and we're left with 2x plus 1 equals E to the 6. The goal is to get x by itself. So to get x by itself, I'm going to first subtract 1, and I'm left with 2x equals E to the 6 minus 1. Then I have to divide 2. So my exact value is E to the 6 minus 1 divided by 2. That's the exact. That's what I'm putting in the calculator to find my approximate. Make sense? So I go to my handy dandy calculator. And again, if you're using Desmos, that's all groovy. I do like the fact that you guys can make fractions on your calculators. I cannot. So therefore, I'm going to use parentheses to separate my numerator and my denominator. So I'm going to press second, natural log. Did not mean to press that twice. E to the 6 minus 1 divided by 2. And my approximate value is 201 and 214 thousandths. How do we do? Okay. Feeling pretty okay about part B? Cool.